Hello students, welcome to all. This is Dr. Vignesh Vermeka, lecturer in geography, Government Degree College for Women's, Begumpet, Hyderabad. In this session, we are going to discuss about volcanoes, causes, types and distribution. The major points that we are going to cover in this module are definition of volcano, causes of volcanoes, types of lava, volcanoes landforms, types of volcanism, distribution of volcanoes and effects of volcanoes. In the present session, that is the volcanoes part 1 video session, we are going to cover the following points: definition of volcano, causes of volcano, types of volcano, types of lava, volcanic landforms. In this, extrusive volcanic landforms and intrusive volcanic landforms. Now, let us start with the definition of volcanoes. A volcano is a vent or a fissure in the crust from which the molten rock material or lava, ash, gases, rock fragments erupt from a magma chamber below the surface. It is called a volcano. Volcanism is the phenomenon of eruption of molten rock, pyroclasts, volcanic gases onto the surface through a vent. Now, let us discuss about the various causes for the origin of volcanoes or volcans. There is a huge temperature difference between the inner layers and outer layers of the earth due to the differential amount of radioactivity. This temperature variation gives rise to convectional currents in the mantle. The convectional currents in the mantle create in convergent and divergent boundaries, that is, weak zones. At the divergent boundary, the molten, semi-molten, and sometimes the gaseous material comes onto the earth at the first available opportunity. The earthquakes here may expose fault zones through which magma may escape. That is from fissure type volcano. At the convergent boundary, the subduction of denser plate creates magma at high pressure, which will escape to the surface in the form of violent eruptions. Now let us discuss about the types of volcanic lava. Magma is composed of molten rock material and is stored in the earth's crust. Lava is magma that reaches to the surface through a volcanic vent. It means when the molten rock material is inside the earth, that is called magma. When it reaches onto the surface through a volcanic vent, the volcanic vent, that is called lava. The volcanic lava is of two types. One is acidic lava and two is a basic lava. First, let us discuss about the acidic lava, also known as andesitic or composite or stratovolcanic lava. The picture on the screen discloses to you about the structure of the volcanoes. The convectional currents inside the earth, where the molten rock material, that is magma, appears in the magma chamber, due to the high pressure, high temperature, the magma escapes onto the surface through a pipe called volcanic vent. When the lava or the magma coming onto the surface, becoming as a lava and accumulating in a conical shape, then it is forming a volcano. And in the later paragraphs, we will discuss about the volcanic lava in detail. The acidic lavas are highly viscous with a high melting point. They are light colored of low density and have a high percentage of silica. When the silica percentage is more, then it is said to be acidic. When it is less, then it's a basic lava. The acidic lavas flow slowly and seldom travel far before solidifying or before getting crystallized. The resultant volcanic cone is therefore stratified, hence the name stratovolcano, and the slopes are steep-sided. The rapid solidifying of lava in the vent obstructs the flow of the outpouring lava, resulting in loud explosions, throwing out many volcanic bombs or pyroclasts. Sometimes the acidic lavas are so viscous that they form on a lava plaque at the crater like that of Mount Pili in Martinique, that is island in the Lesser Antilles, Caribbean Islands. Andesitic lava or the acidic lava flow occurs mostly along the destructive boundaries, that is convergent boundaries. The picture on the screen discloses you about the lava plaque at the crater where the lava is solidified or cooled. And the next is the basic or the basaltic or the shield lava. The basic are the hottest lavas about 1000 degrees Celsius and are highly fluid. They are dark colored basalt, rich in iron and magnesium but poor in silica. They flow out of volcanic vent quietly and are not very explosive. Owing to their high fluidity, the basic lava flow readily with a speed of 10 to 30 miles per hour. The basic lavas affect extensive areas, spreading out as thin sheets over great distances before they solidify or they be crystallized. When the basic lava resultant are coming out from the volcanic vent, the resultant volcano is gently sloping with a wide diameter and forms a flattened shield or a dome shape. Shield type of lava flow is common along the constructive boundaries, that is divergent boundaries. The picture on the screen discloses to you about the magma chamber. This is the magma chamber. The pipe that comes onto the surface. This is called volcanic vent. Lava, magma is erupted onto the earth's surface as a lava. And the place where the volcanic pipe ends at the top of the surface, it is called crater. When the basic lava erupted, the dome-shaped volcanic landforms formed. For example, the Mauna Loa volcanic volcano in Hawaiian Islands. And now let us discuss about the various volcanic landforms. When the magma comes onto the surface, converting into a lava, due to the cooling of the lava, then it forms into various crystals or it solidifies, making the various landforms. Volcanic landforms are divided into extrusive and intrusive landforms based on whether magma cools within the crust or above the crust. If the lava is solidified above the crust, that is on the surface, they are called as extrusive volcanic landforms. If the magma is solidified below the crust or below the surface, then they are called intrusive volcanic landforms. Rocks formed by the cooling of magma within the crust are called plutonic rocks, and the rocks formed by cooling of lava above the surface are called igneous rocks. As we discussed in the previous module, that is rocks, types, distribution. In general, the term igneous rocks is used to refer all rocks of volcanic origin. Now let us discuss about the extrusive volcanic landforms. Extrusive volcanic landforms are formed from material thrown out to the surface during the volcanic activity, during the volcanic eruption. The materials that are thrown out include lava flows, pyroclast debris, volcanic bombs, volcanic ash, volcanic dust, and volcanic gases such as nitrogen compounds, sulfur compounds, and minor amounts of chlorine, hydrogen, and argon, etc. The conical vent or the fissure vent is a form by the extrusive volcanic landform. A fissure vent or a volcanic fissure is a narrow linear volcanic vent or a volcanic pipe through which lava erupts onto the surface, usually without any explosive activity. The vent is often a few meters wide and maybe many kilometers in length. The fissure vents are common in basaltic volcanism, that is a shield type of volcanoes. Conical vent is a narrow cylindrical vent from which the magma flows onto the surface violently. The conical vents are common in andesitic volcanism, that is composite or strato type of volcanoes. The picture on the screen, the left one, discloses about the conical vent. For example, Mount Fusiyama is the best example, and the right is the fissure vent from which the lava is erupting. Mid-oceanic ridges. The system of mid-oceanic ridges stretches from more than 70,000 kilometers across all the ocean basins. The central portion of the mid-oceanic ridges experiences frequent volcanic eruptions. The lava is basaltic, that is less silica and hence less viscous, and causes the spreading of the seafloor. Seafloor spreading is as a resultant of the volcanic eruption. And a composite type volcanic landforms. The composite volcanic landforms are conical or central type of volcanic landforms. Along with the andesitic lava or the basic lava, large quantities of pyroclast material and volcanic ashes find their way to the surface. Andesitic lava along with pyroclast material accumulates in the vicinity of volcanic vent openings, leading to the formation of various layers and this makes the mounds appear as a composite volcano or a strato type of volcano that is divided into various layers. The picture on the screen discloses you about the composite type of volcano. The highest and most common volcanoes have composite cones. For example, Mount Stromboli, which is also known as the lighthouse of the Mediterranean Sea in uh, Lipari Highlands, Mount Vesuvius and Mount Fuji are the best examples of the composite type of volcanoes. And the shield type volcanic landforms. The Hawaiian volcanoes are the most familiar examples of the shield type volcanic landforms. These volcanoes are mostly made up of basaltic lava that is very fluid, and these shield type of volcanoes are not steep sided. They become explosive if somehow water gets into the vent, otherwise they are very less explosive. For example, Hawaiian volcanoes, Mauna Loa, which is an active shield volcano, and Mauna Kea, which is a dormant shield volcano, are the best examples for this one. The figure on the screen discloses you about the shield type of volcanoes. The next is a fissure type flood basaltic lava landforms or lava plateaus. At times, a very thin magma escapes through cracks and fissures onto the Earth's surface and flows after intervals for a long time, spreading over a vast area as a lava, finally producing a layered, undulating, that is, wavy-like structures and a flat surfaces. For examples, the Siberian traps, the Deccan traps in India, Snake Basin in America, Icelandic shield and Canadian shield are the best examples of the fissure type of eruption volcanic or lava plateaus. Crater is another important explosive landform. A crater is an inverted cone-shaped vent through which the magma escapes onto the surface. When the volcano is not active, the crater appears as a bowl-shaped depression, as shown in the figure on the screen that appears on the screen. This is the crater of Mount Fuji or Mount Fujiyama in Japan. When the water from rain or melted snow gets accumulated in this crater, then this crater becomes a lake. It is called as a crater lake. The best examples of the crater lakes are the Loktak lake in Manipur and Lathu in Lathu lake in Maharashtra. Another one is the caldera. In some volcanoes, the magma chamber below the surface may be emptied after volcanic eruption when the lava or the magma disappears. The volcanic material above the chamber collapses into the empty magma chamber, and the collapsed surface appears like a large cauldron-like halo or the tub-shaped feature, which is called as the caldera. When the water from rain or the melted snow gets accumulated into that caldera, then it becomes a lake which is known as the caldera lake. In general, the caldera lakes are also called as the crater lakes. Due to their unstable air moments, some craters lakes exist only intermittently, but they are not permanent. Caldera lakes, in contrast, can be quite large and long lasting also. For example, Lake Toba in Indonesia formed after its super volcanic eruption around 75,000 years ago. It is the largest crater lake or the caldera lake in the world that appears on the screen. Mount Mazama, Cascade volcanic arc that is in the USA, collapsed into caldera which was filled with water to form a crater lake or the caldera lake. The lateral name of the lake formed by the collapse of Mount Mazama is a crater lake. A crater lake in general could be of volcanic origin, volcanic crater lake, volcanic caldera lake, or due to a meteorite impact, meteorite crater or impact crater, or in the crater left by an artificial explosion caused by the humans. Lunar Lake, also known as Lunar Crater, Lonar, Buldana district, Maharashtra, was created by a meteorite impact during the Pleistocene epoch near Latvia. And another form is that cedar cones, excessive landform. It is a steep, circular or oval-shaped hill of loose pyroclastic material that have been built around volcanic vent. That is called the cinder cone volcanic landforms. Then the lava dome. A lava dome or the volcanic dome is a mound-shaped protrusion, that is a structure that extends outside the surface, resulting from the slow extrusion or the eruption of the viscous lava from a volcanic vent. In lava domes, viscous lava or the viscous magma piles up around the volcanic vent. The magma does not have enough gas or the pressure to escape, although sometimes later after sufficient pressure buildups, it may erupt explosively. As shown in the figure on the screen, lava, that dome-shaped protruding from a volcanic vent. Pseudovolcanic features. Pseudovolcanic features are certain topographic features which resemble volcanic forms but are of non-volcanic in origin. They include meteorite crater, salt lakes, and volcanoes. What are meteorite craters? Meteorite craters are the impact craters that have formed or created when a meteorite strikes the surface of the earth, creating a huge depression or a huge basin-like shape, is called as the meteorite crater. And salt plug or the salt dome. A salt plug is formed when underground salt deposits at high pressure become ductile and pierce through the overlying sediments to create a dipole or a dome-like intrusion forced into the brittle overlying rocks. Salt depressions may take the form of salt hills, which exhibit volcanic craters-like features. Salt structures are impermeable and can lead to the formation of a stratigraphic trap, an impermeable layer capable of retaining hydrocarbons. Structural traps, in contrast, are the cracks and folds that can retain hydrocarbons. And mud volcanoes. A mud volcano or a mud dome is a landform created by the eruption of mud, water, and gases from the earth crust or inside the earth. Mud volcanoes have a similar shape to other types of volcanoes and contain several cones. When the mud is erupting through a vent onto the surface is called as the mud volcano. They are usually found near the subduction zones or near the hot springs. Other mud volcanoes entirely of a non-volcanic in origin occur near about oil fields where the methane and other volatile hydrocarbon gases mixed with the mud force their way towards the surface, that is onto the surface. Now let us go to the intrusive volcanic landforms. Intrusive volcanic landforms are formed where the magma solidifies within the crust but not reaching onto the surface. The picture on the screen discloses to you about the plutones and volcanic landforms made by the volcanic activity or the volcanoes. Now let us discuss about the various intrusive landforms made by the volcanoes. They are batholiths, laccoliths, sills, dikes. Now let us go to the batholiths. These are the large granitic rock bodies formed due to the solidification of the hot molten magma or the molten magmatic material inside the earth below the surface. They appear on the surface only after the denudation process remove the overlaying materials. Batholiths form the core of huge mountains and may be exposed on the surface after erosion process. Laccoliths. Laccoliths are large dome-shaped intrusive water bodies, or intrusive volcanic bodies connected by a pipe-like conduit from the below. These are intrusive counterparts of an exposed dome-like batholiths. The Karnataka plateau is spotted with the dome hills of granite rocks. Most of these now exfoliated and are examples of the laccoliths or the batholiths. Another one is the laccolith. As and when the lava moves upwards, a portion of the same may tend to move in a horizontal direction. Wherever it finds a weak plane, it may get rested in different forms in the weak plane. In case it develops into a saucer shape concave to the sky body, it is called as lapolith volcanic. The faccoliths. This is another intrusive landform made by the volcanoes. A wavy mass of intrusive rocks at times is found at the base of the synclines or the top of the anticline in folded igneous strata. Such wavy materials have a definite conduit to source beneath the in the form of magma chambers, subsequently developed as a batholiths. And these are called as the FACO. Another intrusive volcanic landform is the seals. The near horizontal bodies of the intrusive igneous rocks are called seal. The thinner ones are called as volcanic sheets just below the surface of the earth. Another intrusive landform, volcanic landform is the dikes. When the lava makes its way through cracks and the fissures developed in the land, it solidifies almost the perpendicular to the ground when it is moving onto the surface. It gets cooled in the same position to develop a wall-like structure. Such structures are called dikes. These are the most commonly found intrusive volcanic landforms in the western Maharashtra area. These are considered the feeders for the eruptions that lead to the development of Deccan rocks. Dear students, so far we have discussed the following points in the part 1 video of the volcanoes. Definition of volcanoes, causes of volcanoes, volcanic lava, and volcanic landforms. In the next session, we will discuss about the various types of volcanism, distribution of volcanism, and effects of volcanism activity. Till then, stay home, stay safe. And thank you, Anandal. Thank you very much.